I don't think we can stress enough on the point that the universe is really weird and that bizarre things are unfolding in the depths of the early universe. Okay, so just hear me out first. Scientists are completely stumped. At least for starters, their trusted theories are falling apart as mysterious, unidentified objects begin showing up in deep field images captured by the Webb Telescope. These aren't galaxies, at least not the kind we've ever seen. They're unlike anything we've classified before. For decades, astronomers stared at a tiny, insignificant speck of light buried deep in Hubble's old images. Just a faint glow in a sea of darkness. Nothing special, nothing dramatic, just another whisper from the ancient universe. Or so we thought. Because when the James Webb Space Telescope finally turned its golden mirror toward that same unassuming dot, the universe dropped one of its biggest plot twists yet. That little speck wasn't a baby galaxy. It wasn't a cosmic ember. It was a monster. A colossal, fully formed galactic heavyweight born at a time when the universe was supposed to be calm, quiet, and barely getting started. A galaxy so massive, so complex, and so impossibly early that its very existence breaks the rules of cosmology as we know them. In today's video, we will look at how a single pixel of light shattered our expectations, challenged our theories, and opened a new chapter in the biggest mystery we've ever confronted. Stay glued to your screens, because the universe is about to get weird. For years, an unusual point of light sat in the field of view of the Hubble Space Telescope. To our most powerful telescopes, it was just an odd speck, a ghost from an era we could barely comprehend. Scientists couldn't have imagined that this smudge was a monstrous galaxy lurking at the edge of time. And this fit, in a way, with our standard model of cosmology. The theory told us the first galaxies were small, tentative things. They had to form gradually, slowly pulling in gas over hundreds of millions of years. The universe, in its infancy, was supposed to be a quiet nursery, not a bustling metropolis. Finding a fully formed, massive galaxy in this early period would be like finding a modern skyscraper in the middle of a prehistoric village. It just shouldn't happen. And for a long time, everything we saw confirmed this orderly story. But when JWST turned its golden eye toward that speck, what it saw changed everything. When JWST focused on that same patch of sky, the odd speck of light resolved into something astonishing, a primordial galaxy dubbed GZ9P3. Astronomers are now staring at a galaxy that is anything but infantile. We are seeing it as it was only 510 million years after the Big Bang, at a redshift of 9.3. The first shock was its mass. This wasn't a small cluster of first-generation stars. It's a behemoth, already containing several billion stars. It is 10 times more massive than any other galaxy found from this early in the universe. For a galaxy to get this big, this fast, it suggests stars must have formed far more rapidly and effectively than our theories predicted. The second shock came from its structure. GZ9P3 has a strange, complex shape with two bright, dense nuclei. This is a smoking gun for one of the earliest galactic mergers ever witnessed, two primordial galaxies smashing together in the infant universe. This violent collision was likely still underway when Webb captured this image. This is the kind of discovery that rewrites the rules, and it's happening almost every day thanks to Webb. If you find this as mind-blowing as we do, don't forget to subscribe to Cosmic Chronicles, your gateway to the universe, where you'll discover the latest mind-bending breakthroughs in cosmology and the mysteries of space. So how is it even possible to see a galaxy that existed over 13 billion years ago? It comes down to the speed of light. The light from GZ9P3 has been traveling for so long that we are seeing it as it was just 510 million years after the Big Bang. JWST isn't just a telescope, it's a time machine. But as the universe expands, it stretches the light traveling through it, a phenomenon called redshift. JWST's genius is its ability to capture this stretched, ancient infrared light. By measuring GZ9P3's precise redshift of 9.3, astronomers can calculate exactly how far back in time they are looking. But they didn't just see the galaxy, they analyzed its light to read its chemical history. They found evidence of heavier elements like silicon, carbon, and iron. Astronomers call these metals, and they are only forged in stars and scattered through space when they die. Seeing them this early means one or more generations of massive stars had already lived, died, and enriched the cosmos. This suggests galaxies may have become chemically mature much faster than anyone thought possible. Finding this impossibly large and mature galaxy isn't just a new record. It's a direct challenge to our cosmological models and has worsened what some call the crisis in cosmology. For a galaxy to get this massive, this mature, and this quickly, something is wrong with our theories. This discovery adds to a growing pile of cosmic discrepancies. For years, astronomers have faced the Hubble tension, where different methods for measuring the universe's expansion rate give conflicting results. More recently, the S8 tension has emerged, revealing a mismatch between how clumpy our theories predict matter should be and what we actually observe. GZ9P3 is a perfect example of this chasm between theory and observation. Its furious rate of star formation, its early massive merger, and its surprising chemical maturity are all features that the standard model of cosmology struggles to explain. A new model may be required to explain how galaxies could grow so large and become so chemically mature so fast. The discovery of GZ9P3 is not an ending, it's a spectacular beginning. It proves there could be a whole population of these impossible early galaxies out there, waiting to be found. Each new one JWST finds will be another piece of this baffling puzzle. Scientists are now pushing the telescope to its absolute limits. Are there other behemoths like GZ9P3? Are they all the products of violent mergers, or did some grow huge on their own? And what does this mean for the supermassive black holes at their centers? If the galaxies grew this fast, did their black holes grow just as quickly? These are the questions that will drive the next decade of astronomy. We are no longer just guessing what the early universe was like. For the first time, we are truly seeing it. GZ9P3 is a beautiful, baffling monster, and it's a sign that the golden age of cosmic discovery is just getting started. From an odd, lonely point of light in Hubble's eye to a magnificent, merging monster in Webb's. The story of GZ9P3 is the story of modern astronomy. We build these incredible machines to confirm what we think we know, but their greatest gift is in showing us what we never thought possible. The universe, it turns out, was in a much bigger hurry than we were. Its first chapters weren't a slow crawl, but a brilliant, violent explosion of creation. The textbooks are being rewritten, and as Webb continues to stare into the dawn, we can only wonder what other impossible things are waiting for us in the dark. What do you guys think? Does this excite you, confuse you, or a little bit of both? Drop in your comments to let me know. And if you enjoyed this journey back to the beginning of time, please consider liking this video and subscribing to Cosmic Chronicles. Thanks for watching.